Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. My dear students at Rital International Academy, grade 11. This is your teacher's Tariq Abanze, physics teacher. I hope you will stay healthy and safe at home. Today we will start the new chapter with you. We know this chapter as circuit element and DC circuits. You know that at Baron's book you already hold it. Chapter 12. Throughout this video, I do believe you will be able to define the principal components of a DC circuit and solve some problems related to DC circuit. At the start, let us try to understand and to begin what do we mean by DC element or circuit elements. We will start by this element, a known element, we know it as a battery. It is one of the major elements in the battery. Without battery, no work for circuit. The purpose of a battery is to create electric potential. So the main purpose is to create electric potential. What is the purpose from this electric potential? It will create battery. It will create pressure on charges stored inside the battery and make what we call it as a current. So this is the diagram for a battery. This is how we draw it, or this is conventional. Draw it on paper here. In reality, here as we draw it on our questions. Okay. We know this is the positive terminal, and this small one we call it a negative terminal. So again, that's mean as long you see this in your battery, you know this is the positive terminal and this is the negative terminal. And when a wire is connected to a positive terminal of a battery, charges flow as a current through the wire on their way to the negative terminal. So let us try to apply it. I have this wire from positive terminal this way, and I could add this one too here. Okay, and this one. Now you could see now current comes from positive terminal through the wire here. This is red arrows, and come here through a wire and go back to the negative terminal. So this positive terminal, we are connected to our wires from positive. Current again move from positive terminal through our wires until it's reached the negative terminal here. Now we will start with the second element of a circuit. This element we know as a resistance. It has this diagram or reality. It has this diagram reality, but we draw it on our lesson or in physics classes as this way. Is a device with a known amount of resistance. As a result, resistors can be used to control current flow in the various branches of a circuit. So, a resistor playing a significant role on controlling a device or circuit. It controls a current flow in the various branches of a circuit. The resistance, it has this values. Ohm. It has this unit as ohm, and it's known as R. We give it a symbol as R, capital letter, of course. So resistors are rated by how much they can resist the flow of current. The actual measurement of resistance is in unit ohm. We give it this symbol. We call it ohm already. Ohm law can be used to determine the resistance of ohmic resistor. This is what we call it, the Ohm law. V equal I R. So V is a symbol for voltage, I is a symbol for current, R is some symbol for resistance. So I have this voltages, 3 batteries. Each one of this battery has a voltage with 1.5. I have this wire, and I have current is equal 9 milliamp. You know, total voltage 1.5 times 3, 4.5 voltage. The resistance we have it 500 resistance. If I could take the amount of current based in this 4.5 over 500 to calculate the current, solve for I, divide by R for each side, and right here 4.5 volt equal I times 500 ohm, divide by 500 for each, you will get 9 milliamp. Now we will study the relationship between resistance and current. So let us try to increase the resistance here, and when we increase resistance, try to look at the current, or decrease resistance. With decreasing resistance, you could see that current became higher, to get a higher value comparing to the previous one. So here we decreasing the resistance, we have a higher current. If we increasing the resistance, we have a small amount of current, so it is inverse proportional between both of them. The resistance with this value, we call it an ohmic resistor, which is we could control it by Ohm's law, V equal IR. Okay. Now voltage and current. If I increasing voltage, I increasing current. You could see that. If I decreasing voltage, I decrease current. So the relationship between voltage and current is directly proportional. Okay. The third one here we have light bulbs. Light bulbs are essentially resistors that give off light. It's a resistors that give off light. The principal difference between a plain resistor and a light bulb is that light bulb uses some of the energy dissipated through the resistance. So light consumes some energy, unlike resistors. So it has this. It uses it to eliminate this light here. This is what. So as long we see the light bulb, that means we have a resistor, and it's based on ohmic law. What we see it previously, V equal IR. Now we have this element. We call this element as a switch. It has this term in reality, but in schematic way we draw it in like this. The purpose of the switch is to direct current flow around a circuit. In a schematic diagram of a circuit, a switch is represented as a line. We have it here as a line at an angle to the circuit. So in this figure, or in this diagram, we could see what do we mean by circuit. So the purpose from this lesson was to identify the circuit element, the main circuit element. We define what do we mean by voltage, we define what do we mean by resistor, what do we mean by light bulb, wires, and how current flow from positive terminal to negative terminal. Not in this way, it's on a circuit, passes through a circuit until it's reached the negative terminal. And we identified what do we mean by switches on electric circuit. I hope you will remain safe. So thank you everyone, and goodbye.